Okay, so next up we have Denis Jannot, and Denis is going to be talking about advanced authentication patterns at the edge.
Hi everyone, welcome to this session about advanced authentication patterns at the edge. I am Denis Jannot, Director of Field Engineering in EMEA at Solo.io. So let's start with a little bit of background. Obviously, all of you are aware that applications are now like developed with microservices, and I would say that most of you will agree that these microservices tends to now run on Kubernetes clusters. And one of the first questions people are asking as soon as they start to deploy their application on Kubernetes is, how do I expose my application to the outside world? And the standard answer for that in the Kubernetes world is to use an ingress controller like Nginx or HAProxy or something like that. And it works. You can expose your service, you can secure it with TLS, you can do some basic routing. But very quickly, we have more and more applications deployed in the Kubernetes cluster, and each team reinvents the wheel in terms of managing the authentication, for example. So you have like one application that wants to secure the access with OAuth 2, another one wants to use like Jannot tokens, another one want to use like API keys, or even like a mix of different options. And they also need some capabilities that you generally find in a traditional API gateway that runs outside of Kubernetes. Some things like rate limiting, web application firewall, and so on. So there are like different challenges, right? So each team reinvent the wheel, like I said. The implementation, in fact, is even different. Like one team using Java, another one like is using Node.js, and so they would use like different libraries to do the same thing, right? And instead of that, I think everyone would agree that application teams should focus on the business logic instead of spending time on this authentication mechanism. And also the security team doesn't have any visibility on what's configured for each application. So it becomes quite difficult for them to understand if there are any potential security issues there. And as I said, you still need some other security mechanism, and you need to implement them outside of the Kubernetes cluster. So what about like using a Kubernetes native API gateway instead of that? So the idea here is that you would perform the authentication at the gateway level, and you would have like different options like OAuth, like Jannot tokens, API keys, and so on. And basically the API gateway performs the authentication and then pass some information to the backend services to let them know who is the user that has been authenticated, for example. That could be like I add like a header with the user email, for example, or other information. Basically, any information that you get from a claim that is in the Jannot token provided by the end user or the Jannot token returned by the OAuth provider, for example. And what's nice as well is that these Kubernetes API gateways, they can generally do much more than just authentication, right? So you can do like rate limiting, WAF, but also like things like transformation and so on. And you will see, I will do like multiple demos to try to demonstrate that in a nice way. These API gateways can also be used, they can run inside the Kubernetes cluster, but still be used to expose applications running in legacy environment, like in VMs, for example. They can also be used to expose modern services running in functions, like in Lambda, for example. They can discover these Lambda functions and expose them to the outside world. So like a lot of benefits, authentication performed at the API gateway level. The team can now focus on the business logic. everything is configured through Kubernetes custom resources. So that's why we call it like a Kubernetes native. And that means it's GitOps friendly, right? I can have all the YAML corresponding to the way I want to deploy my application on Kubernetes in a Git repository, and at the same time, the YAML corresponding about the way I want to secure my application. So the configuration of the gateway in the same repository, which is very nice. And I will show you some examples very soon. And other mechanism can be enforced also at the gateway level, and you have like nice visibility for the security team, right? They can go and look at the gateway configuration and understand very quickly about how the access to each application is secured. So in that talk, I will focus on our Kubernetes native API gateway, which is called GlueEdge. And GlueEdge is based on Envoy. I am sure that most of you are familiar with Envoy, and I will speak about it like in a minute. But basically, GlueEdge is like a management plane, a control plane, sorry, for Envoy. And Envoy is the data plane. And you configure everything, as I said, through custom resources in Kubernetes. GlueEdge reads this configuration and translate that into Envoy configuration. And if you look at the architecture, you see on the left the Envoy piece, and you see these different boxes that represent filters. So in Envoy, a request comes in and it goes through a filter chain, and each filter in the chain can modify the request in one way or another. So for example, the request comes in and you want to perform authentication, then this filter will not perform the authentication by itself, but it will call an external authentication server that will perform the authentication and say yes or no, do I want to accept or not this call. The same, if it's accepted, it can go through a rate limiting filter that will call a rate limit server that will define if the limit is reached. Generally, this server, and it's what we do in GlueEdge, is using like Redis to persist information about the request and to be able to determine if the limit is reached. And then there are like many things that can be done directly in Envoy in a filter without even calling like an external component. And that's what we have done. Like we have created like a filter for interacting with Lambda function, another one for performing transformation, another one for web application firewall, for Jannot authentication. We don't use the external authentication server for that. We perform that directly in Envoy. So there is like an open source version of GlueEdge, but if you use the open source version, then you have to build your own external authentication server, your own rate limiting server, and you don't get all these filters. You get some of them, but you don't get like the web application firewall or Jannot, and basically everything that is really related to security is in the enterprise version, and that's what I will use in the demo. So why Envoy? First of all, it's coming from a neutral foundation, the CNCF, the same as Kubernetes. So there is no one single company that drive the roadmap of Envoy. It has a very large community. It is used at scale by many companies. It's really designed to be dynamically configured through a control plane. That's also why you see it like very commonly used in service mesh. Most of the service mesh technologies are using like Envoy. The most popular one, Istio, obviously is based on it, which is also a good reason for adopting like an API gateway based on Envoy, because when you will adopt service mesh in the future, and I think like most of you will at some point, then having the same technology for the gateway and for the mesh allows you to have like the metrics in the same format, allows you to debug the issues the same way, and so on, right? So it's I think it's very interesting to invest on a gateway based on Envoy for all these reasons. So when I say Kubernetes native and I say we can drive the configuration through Kubernetes resources, basically this is what I mean, right? So you will define in a virtual service custom resource which domain you want to listen to. Like here I say I have a request starting by /app1. I want to perform authentication, and the authentication is defined in this external object, and I want to delegate the action to this root table so that a team can be responsible for managing a specific domain. Then the application team can manage all the different paths, like they can have different routes for different microservices and so on. And then you can use like an external object to define the way you want to authenticate the user. And you see here we have a simple example with OAuth 2. We will go through that in the demo, but you can also chain together multiple steps in the auth config, and we will also see that at the end. So let's jump into the demo, because I think it's the best way to understand the benefits and to learn about how GluEdge is working. Okay, so in this environment, I have a Kubernetes cluster, and if I look at my pods, I can see that I have this glue system namespace where I have different components. Some of them are optional, and I won't go through the full details, but basically what you have to remember is that the gateway proxy pod is Envoy. We have like the control plane components here and here. We have the external authentication component that is running there. We have the rate limit components here, and both of them can use Redis for different purposes. So what I'm going to do here is that I deployed Keycloak already, and in this server, and I will configure it just like with these few commands. And you see it will create like a user 1 with the password, and another user 2 with the same password, but they will have two different email addresses, right? You see the first one has an email address that finished by solo.io, while the second one has an email that finished by example.com, right? So it looks like that. I have like GluEdge, and that will use Keycloak, for the authentication. So I can create like a Kubernetes secret that contain my Keycloak secret, and then I create this auth config that I spoke about before. So in this auth config, you can see that I have like the URL of my application, the URL of Keycloak, just like basic information about how to contact and interact with Keycloak. And then I have my virtual service. You remember I described that just before. It's one of the most important custom resource in GluEdge. And you can see here I will add this option to it. So to say, when I have a request with starting by /, then I want to send a request to the book info product page, and I want to perform authentication using the auth config that I have like just created before. So now if I open like Chrome, I will see, I have SSL here, and I can authenticate with user1 and the passwords, and I have access to my application. So you see it's very easy. I was able to configure it. It's a very simple case, right? I just want to secure the access with OAuth 2, but there will be at the end, I will show you like something a little bit more advanced, and even using like authorization and so on. But before that, I want to show you also a few other capabilities that we discussed before. Let's say I want to apply rate limits. Then I have another custom resource that case, it's called like rate limit config. I say I want to have like a limit of 10 requests per minute, and I don't have any specific key, right? That's a very basic example. But I could say I want to limit to 10 if I have a header with, I don't know, tenant equal tenant 1, or things like that, right? And I could have like a lot of different combination of rules to have like really fine-grained rate limiting. But here I just show you like a basic example. You create a rate limit config like we created the auth config before, and in that case I reference the rate limit config here, so I know that it's applied to this route. And you see you can do it here at the root level, and that will apply only to this route, but I could put this option at the domain level, and then it will apply to all the routes. So we have like a lot of flexibility here. So if I just like refresh many times, you see after 10 times I get this 429 response code, meaning that I've been rate limited, right? So I can delete this basic rate limit config, and here I can update it and give also like different options depending if I am like authenticated or not, right? I would say if I am an anonymous user, I want to have like just 5 requests per minute, but if I am authenticated, then I can have like 20 requests per minute. So as I said, you can have granularity about different headers of combination, or you can have like also this option where you set like different rules for different users, or different rules for authenticated and not authenticated. You see here I am not authenticated, and I get like this rate limit after just 5 requests. Another thing we spoke about before is like web application firewall, right? So what we did is that we took mod security, which is very popular, and we put it inside an Envoy filter. So that means that now I can update my virtual service, and I can add any mod security rule, right? So here I can say I don't want like any payload bigger than 1 byte, right? So it's just like for demo purpose, obviously, but you see it's an example. You can limit the size of the payload, you can whitelist some IP addresses, range, or these kind of things, right? So now if I run a curl command and I just like send a body request, right, with some data, it will be directly bigger than 1 byte, right? And you see I get this error, right? I get it's refused, and I get an error message telling me why it has been rejected by my web application firewall. There could be other option, like you could block certain user agent, for example, right? So if I have a user agent header with a value scammer, then I want to reject it, right? So again, I just send like a curl request with this user agent, and I am blocked by web application firewall. You have like a lot of different options. I'm just like giving you like a very quick overview. Another thing that is really nice is the way we can interact with the request, right? So for example, here, we said we want to specify like a rate limit, and we just got like this 429 error, right? So it was not really nice, you just get this error. We could say when there is a response code 429, then I want to change the body, right? And I want to change the body so that now, instead of like this just 429 error, I get like a 200 response, but I have like a body that display that in a HTML format that is like a little bit nicer. Oh, in fact, I put it in this other applications. So here, you see, I got this like modified response. So that's just an example, right? You can do whatever you want in terms of transforming the request header, request a response header, response body, and things like that, right? We can also like define where we want to do this transformation. So sometimes it's nice to do transformation before we do authentication, or after we do authentication, or things like that, right? So here we have what we call an early transformation, so that applies before the authentication, right? So I can apply this transformation. You can see I will transform the response, and I will add this JSON content type, and I will change the body as well, right? So I can just go there, and if I if the status is 401, right, I can simulate that because I use the HTTP bean. So I want to get a 421, so I just have to call this, right? And you see the transformation here, right, that is happening. While if I run like a normal request with like the code 200, right, it will not like perform any transformation, right? We have like another example where we can take the data from another header using like a regular expression and create a new header based on the value we got from the regular expression, right? So you can see here we can have in the request like a header called x my initial header, and it has this format bearer and something, right? And there is the regular expression here, and we want to create a new header with just the value here. We want to remove bearer basically, right? So that could be very nice when you want to maintain compatibility, right? So I just do that, and here I send I just like again send a request here, and you see my initial header has this bearer, and I create now a new header that has just the value, right? So again, it's quite useful. We can also do that, use some transformation to get like to extract some information from the Jannot token that we get after the authentication. So you see here we say we want to use the Jannot filter so that we take the email claim that is returned by in the Jannot token after we authenticate with Keycloak, and I want to create a new header called X solo claim email for that, right? So we do that for just updating again the service, and if I refresh my my token here, like my page, sorry, so you can see here now I have this X solo claim email that is received by the backend application. So you remember we do the authentication at the gateway level, but now it's important also for the backend application to know who is the user that has been authenticated, right? So now it knows it, right? So it doesn't have to perform the authentication, but it still need to know in many cases who has been authenticated, right? So that's a very typical use case. And then we can also, as I said, chain together several steps in the auth config, right? So we did like create a auth config where we want to do authentication with Keycloak here, but we can also have a second step which is performing authorization with OPA. So we just like update the auth config, and we don't need an OPA server. This is what's really nice. We use basically the OPA library directly in our external authentication service, so that you just need to provide the rego policy in a config map. So you see here in the policy, what we do is that we extract the claims and we check the email claim. And the email claim has to finish by solo.io. If it's not the case, then we will reject the authentication. So if I just do that, and then we just take again the virtual service we had before, but we still reference this auth config object, then you can see that here I can still access it, right? Because I am like authenticated with user 1. But let's say if I go here and I try to access the same page with user 2. I know this one doesn't finish by solo.io, right? It's a different email. Then I am not authorized. So like it's a lot of different examples, right? I wanted to show you really the fact that you can drive everything through YAML, that you can take advantage of authentication at the edge, perform authorization as well, and also like take advantage of like a web application firewall and all these different rate limiting and all these different things. You can go to the doc and you will see like many guides that show you how to handle lambda functions, for example, gRPC. In terms of security, you have a lot of other options, right? In terms of authentication with API key, LDAP, creating your own plugins, and so on, right? So thank you for your time. I hope it was useful.
Thank you very much, Denis. I just want to start by apologizing for the video quality during the video, during the stream. Denis has actually posted his video in the Slack channel, so if you want to, in the short term, have a look at any of the command line or terminal in a high resolution, then you can do that. We will also, when we post this recording afterwards on YouTube, it will be in a higher resolution as well. So apologies for the technical issues that we had with the stream. So I just want to, thanks for joining, Denis. I just want to have a look at and see if there are any questions about your talk that weren't related to the video quality. People did seem to be very interested in the talk, though. So that's always a good
In any
sign.
case, like we are always on Slack, right? You can find me in the CNCF Slack or in the solo Slack. So don't hesitate to come here. As you said, I gave the link for the recording, so perhaps it will be easier to have questions after you watch it with seeing all the command lines and all the stuff. So don't hesitate to take the time to watch it and come and ping me on either the CNCF Slack or the solo Slack, and I will be happy to answer any question there.
Great. Well, thank you very much for joining and for doing a talk.
Thank you for inviting me for the talk, and hopefully you will have a lot of other great sessions moving forward, I'm sure.
So now we're going to a short break, and we will be back on track 2 at around 1 o'clock, I believe. Is that correct, Paula? Am I right? I'm thinking...
I think we're back at 10 to 2, 1:50.
10 to 2, 1:50. All right. Well, until then, thank you very much.